So I'm going to talk to you today about specific heat and how to calculate transfer of energy. So in our previous laboratory investigations, we saw that energy can be transferred between two objects that are of different temperature. So you had a beaker. In many cases, you had it at a certain temperature, right? Maybe 80 degrees Celsius. And you took some pieces of metal, maybe copper, and it was at room temperature, which is around 22 degrees Celsius. And then you put the copper into the hot water, and you notice that the water became cooler, right? The temperature of the water went down, and the temperature of the metal, when you took it out, you notice that the temperature of the metal went up. So that means they're moving towards thermal equilibrium. The temperature is somewhere in between 22 degrees Celsius and 80 degrees Celsius. So at the end of that investigation, you figured out that there were several factors that affected transfer of energy. So one of them was the temperatures of the two materials. Another one was something special about the materials themselves. And then the mass of each material as well played a role. You all figured this out on your own. So now we're trying to understand, okay, how do we calculate those values? And that brings us to this equation. There's actually two equations, but they're exactly the same actually. Just in some cases, S is used to represent some property about the materials. In other cases, it's C with a SP subscript. In both those cases, the C, SP, or the S, that refers to specific heat capacity. And specific heat capacity is the amount of energy it takes to increase 1 gram of a substance by 1 Celsius. And so that energy can be in joules or it can be in calories. So joules is the metric system measurement of energy, and calories is the imperial system of energy measurement. M in this equation represents mass. Q represents heat energy. And delta T refers to the change in temperature. And as you remember from the labs that you did, you figure out the change in temperature by taking the final temperature, T subscript F, and subtract the initial temperature, T subscript I. So delta T is equal to TF minus TI, the final temperature minus the initial temperature. So basically what's being asked on this quiz is that you solve this equation. So what are some keys to solving energy transfer problems? Well, one of them is to identify the variables in the problem. Then you plug it into the equation, and then you solve the problem with the correct units and doing the correct math. So let's do two examples to show you that this is not so hard. So this question is saying, what is the specific heat of a substance that absorbs 2,500 joules of heat when a sample of 100 grams of the substance increases in temperature from 10 degrees to 70 degrees Celsius? So next to the what is, you see the thing that you're solving for, right? Specific heat, which is the S. You have joules, which is the energy, so that's the heat energy, so that's Q. You have G, right, grams, which is the mass. And you have from 10 degrees to 70 degrees. So this is from is the initial temperature, and to means the final temperature. So now, there's two ways that I think of solving this problem. You can either plug all the numbers in, or and then do the math, or you can solve for the variable that you want, which is what I'm going to do here. You divide both sides by m delta t, And you notice that the m cancels and the delta t cancels. And so you're left with S equals Q over m delta t. And then you can just plug it in. So the Q is 2,500 joules. The m is 100 grams. The 70 minus 10, right, is going to be 60. You want to show the work. And then you want to make sure that anything on the bottom of the fraction is divided, anything on the top of the fraction you multiply. So you do 2,500 divided by 100 divided by 60, or you can do 60 times 100 and then divide that into 2,500 joules. And then the correct units for this answer would be joules over gram Celsius. And you can type this in your calculator, so then you put your answer right here. Okay, as I said, the other way to solve this problem is just plug the numbers in first without doing this kind of manipulation here. It all depends upon your proficiency with algebra. I'll solve this problem that way. So here on this next example, you have 100 milliliters of 4 degrees Celsius water, and it's heated until its temperature is 37 degrees Celsius. If the specific heat capacity is 1 calorie per gram Celsius, so that's the energy it takes to raise 1 gram of water by 1 Celsius, you calculate the amount of heat energy needed to cause this rise in temperature. So here's the equation, Q equals ms delta T. And so I'm just going to plug the numbers in here. So the mass, we see that it's 100 milliliters. Now we learned from the density section of this course that 1 milliliter is 1 gram. So we know that if it's 100 milliliters of water, it's 100 grams of water. So we put 100.0 grams here. And then we put S, which is 1 calorie per gram Celsius. And then the TF is 37 degrees, right? This is the TF. And this one is TI, because it's where it started. This value, as I've already plugged in, is the S, because it says specific heat capacity. 37 minus 4.0 degrees Celsius. And then you do 100 times 1 times 33, which is what you get from this. Now notice that the grams here is on the top and here it's on the bottom, so it cancels. And here, Celsius is on the top, and here it's on the bottom, so that cancels as well. So then you're left with the answer, calories, which is what Q is. Q, remember, is heat energy. So it's going to come out as calories or joules, and then you do 100 times 1 times 33, and you're going to put your answer right there. Again, this is just plugging to a calculator once you isolate the variables, which brings us to the keys to solving energy transfer problems, which I mentioned earlier. The key is to identify the variables, you plug it into the equation, and you solve with the correct units. So please make sure you write down any questions and ask them in class, and then you practice, and then you try the quiz. So I hope that's helpful. Have a good day. Bye.